So in our last class, we have seen what is network ID and broadcast ID. Network ID is the first IP address of your network and it is used to recognize the complete network. Broadcast ID is the last IP address and it is used to recognize it is used to send the same packet to all the devices in your network, or it is used to broadcast the packet in your network. Now guys, we'll discuss about subnet mask. So while configuring the IP address, we have different options like IP address, subnet mask, default gateway. We have already discussed what is the IP address. Okay, then let us see what is the subnet mask here. Guys, any idea what is the use of subnet mask? Any idea? Anyone? Hello. Any idea, guys? Okay, just give me 1 minute. Okay. Sorry. Very- I'm very sorry. Oh, class. Oh, no. So very sorry. अभी class will be call. Hello. Yeah, guys. What is subnet mask? Let us try to understand. So subnet mask, it is used to differentiate the network portion and host portion. What does it mean? Let us try to understand. Let us say there is one IP address 192.168.1.1. So guys, what is the class of this IP address? You guys are available. Can you hear me, guys? Everyone is available. I'm talking to you.
Yes, yes, we hear you. C.
So what is the class of this IP address?
C.
Class C. In class C, how many network and how many host portions are there?
A three
Three
portion
network and one
network, one
host.
portion
Three
host.
network portions and one host portion. All right. So how will you tell the computer that this IP address is having three network portions and one host portion? We use the subnet mask. So in place of network portion, we will write 255. And in place of host portion, we write 0. So it is used to differentiate the network portion and host portion. So subnet mask differentiate the network portion and host portion. In class C, we are having three network portions and one host portion, and the default subnet mask of class C is 255.255.255.0. Class B's default subnet mask will be 255.255.0.0 because it is having two network portions and two host portions. Class A's default subnet mask will be 255.0.0.0 because it is having one network portion and three host portion. So remember the default subnet mask of all the three classes. All right. So guys, whenever we try to configure the IP address from any class, it will automatically take the default subnet. So let us quickly verify it. Let us assign the IP address from class C 192.168.1.1. And if you see, if I press tab, it is automatically taking the default subnet mask of class C. Let me assign the IP address from class B. And if I press tab, it is taking the default subnet mask of class B. And let us provide the class A IP address. And you can see it is taking the default subnet mask automatically. So the subnet mask is used to differentiate the network portion and host portion. And guys, we are having ping command. So let us discuss about the ping command. Ping command is used to check if two devices can communicate with each other or not. Let us say we are having two computers. Okay. And let us say the IP address of this computer is 1.1.1.1 and the IP address of this computer is like 1.1.1.2. And you want to check whether these two computers are communicating with each other or not. The connectivity is there between these two computers or not. You will use the ping command. So you will open the command prompt. This black screen is known as command prompt. Okay. and you will go to the command prompt and you will type ping, and whatever the IP address of the destination is 1.1.1.1, and if it is pinging, you will get the replies like this. You will get 4 replies. Let me show you. Okay, let us say we want to ping google.com. We need to check the connectivity is there between my computer and google.com or not. I will open the command prompt. This is the command prompt. You will go to search and you will type cmd. You will get one black screen here, and on this black screen you will type ping www.google.com. If the reachability is there, you will get the replies like this. So we have got 4 replies here. Reply from this is the Google IP address, bytes 32, time 39 milliseconds, TTL 58. Okay, we will see. Okay, what is the meaning of bytes 32, time, TTL, etc. And this is the IP address of Google server, and it is getting 4 replies. Why it is getting 4 replies? Okay, whenever we ping any destination, it will send 4 requests. It will send 4 packets. These packets are known as echo request. If the destination is available, so it will send back 4 responses. It is known as echo response. Okay, that is why we have got 4 replies here. Okay, now guys, what information you will get with this ping command? You will get the information like destination IP address. You will get the packets as so. If we have just discussed that, it will send the 4 requests. It will send 4 packets, that is known as echo request. So this is the size of that packet, 32 bytes, and you will get the time in milliseconds. So what is the time? What is this time in milliseconds? It is the round trip time from my computer to Google, Google to my computer. Okay, this is the round trip time. So the first packet took 15 seconds from my computer to Google, Google to my computer. So you will get the different times here for all the 4 packets. So 15 milliseconds, 18 milliseconds. Then we are having another field called TTL. Okay, we will discuss what is this TTL. All right. So guys, TTL value, it is used, okay, for 2 things. Or you can say there are 2 uses of this TTL value. Let us try to understand both the uses. The first use or first job of this TTL value is to count the number of hops. Okay, I will tell you, okay, what is the meaning of counting the number of hops. And the second use is stopping the loop. So guys, remember these 2 points. Okay, what is the use of TTL value? The first use, okay, we will see both the uses. Okay, don't worry. First use is to count the number of hops. The second use is to stop the loop in your network. So let us see what does it mean, okay, of these 2 jobs. The first use, as we have discussed, it is used to count the number of hops. Okay, let us try to understand what does it mean. So if you see in this example, we are having the google.com, Google server, and let us say this is my computer. Now, between the google.com and my computer, there are 3 routers. These routers are referred to as hops. Okay, so between my computer and the destination, or between my computer and google.com, I am having 3 hops. Okay, now whenever I try to ping any destination, the TTL value is added by the operating system. Okay, so this TTL value, it depends on which operating system you are using. If you are using Windows operating system, so it will add the TTL value 128. All right. If you are using Mac operating system, it will add the TTL value 255. Okay, whatever the value, the usage is same. So let us focus on 128. Let us say we are using the Windows operating system, and Windows operating system will add the value 128. Then it will send the packet to the router one. As soon as it reaches, the packet reaches the first router or the first hop, the value will be decremented by 1 and it is 127. Then R1 will forward the packet to R2, and again the value is decremented by 1 and it will be 126. Then R2 will send the packet to R3, and again the value will be decremented by 1 and it will be 125. Then the router will forward the packet to the destination. Again, the value will be decremented by 1 and it is 124. So how many hops are there from source to destination? 128 minus 124. There are 4 hops between source and destination. So this is the first use. The first use of TTL value is to count the number of hops. Clear, guys?
Yes, yes, sir.
All right. Let us see the second use of this TTL value. So guys, TTL value, it is used to stop the loop in your network. So what does it mean by loop? Let us try to understand. Then we will see how it is stopping the loop. So again, let us say we are having the google.com and this is my computer, and between google.com and my computer, okay, let us say there are 4 routers, or router 1, router 2, router 3, router 4. Now, what is the source here? The source is 192.168.1.1 and the destination is google.com. Okay. So the packet, okay, let us say we want to ping google.com, the packet will go to R1 and it will add the, let us say there is no TTL value. Okay. There is no concept of TTL value. The packets will be sent without any TTL value. The request will go to R1. R1 will forward the request to R2. R2 will forward the request to R3. Okay. So R3 should forward the packet to the google.com, but there is some technical issues in the network. Due to that, R3 could not send the packet to the destination. Instead of sending the packet to the destination, R3 has sent the packet to R4. R4, it will send the same packet to R1. Okay, it was sent by, originally it was sent by R1. Okay, and the same packet R1 is receiving from the other direction. Then R1, what it will do? It will send the same packet to R2, R2 to R3, R3 to R4, R4 to R1. Again, R1 will send the packet to R2, then R3, R4, and it will form the loop here. Okay, this is the meaning of loop. Okay, sending the same packet between the same devices over the same link, it is known as loop. So what is the problem here? If there is any loop in your network, it will consume the bandwidth. Okay, we are talking about only one packet. Let us say all the devices are making the loop in your network, so it will slow down the network, it will consume the processing of the router. So there are so many problems, okay, if you are having the loop in your network. Okay, so how will you avoid the loop? This TTL value helps us to terminate the loop. Okay, so let us say we are having the TTL concept now. Okay, then this PC will add the value 128. The TTL value gets decremented and it is 127. Then R1 will send the packet to R2, 126. R2 is sending the packet to R3. The TTL value is 125. Again, it is having some issues. Network is having some issues. Due to that, it is sending the packet to R4 instead of sending the packet to the destination. And the TTL value gets decremented by 1 and it is like 124. Then 123. And again, it has formed the loop. But guys, this loop will not be there permanently. As soon as this TTL value gets 0, this packet will be discarded and it will terminate the loop. This is the second use of TTL value. It is used to stop the loop in your network. Okay. So when TTL hits 0, the packet is dropped to avoid the trouble. Clear, everyone?
Okay.
So it was about the ping request. Now, let us say you are sending a ping request, okay, and you might not always get the reply. There might be some problem in your network. So instead of getting the replies, you are getting some error messages. So instead of that, you could receive the ICMP error message. Okay, the error messages like request timed out. You can see instead of getting the replies, we are getting the errors, request timed out. Or sometimes we get the error like destination host unreachable. Okay, so let us try to understand when we get request timed out message and when we get destination host unreachable message. Okay, so the first possible reason of getting this request time dot message or error reporting message, the destination. Okay, let us say we are pinging google.com. I'm just giving the example, and we are getting this request time dot message, which means this Google server is down. Okay, it is powered off. You need to check whether it is powered off or power on. Okay, so if it is powered off, you need to turn it on. All right, this is the first possible reason of getting the request timed out message. Guys, the second possible reason is this server is not connected to the network, or there is a problem with this cable. Okay, maybe the cable is broken. So we need to check. Okay, we need to check the server first. If it is powered on, then we need to check whether this server is connected to the network or this cable is working fine or not. This is the second possible reason of getting the request timed out message. And guys, the third possible reason, we are having the firewall. Okay, this firewall is stopping the ping request. So again, we need to check with the security team, and we should ask them whether they have blocked the ICMP messages reporting or they have blocked the ping request or not. Okay, so if they didn't block it, okay, what is the fourth possible reason? The fourth possible reason is this device, okay, this server is having its own firewall. Okay, we are having one external firewall, and the operating system of the server will have one firewall, okay, that is known as internal firewall, and maybe this operating system firewall is blocking the ping request. And guys, most of the time when you are getting this request time dot message, okay, so you need to check the firewall of this operating system. Most of the time this is the reason. Okay, the the operating system firewall is stopping the ping request. Let me show you. Okay, even means client operating system like Windows 10, 11, 7, 8, all of them are having their own firewall. Let me show you the firewall of my computer. We'll go to search and we'll type firewall.cpl. Then we'll press enter. Guys, this is the firewall of my computer, of my operating system. If you see, it is saying that it is a Windows Defender firewall. And what is the current status of this firewall? This firewall is turned off. Okay, if you see the red color, which means it is turned off. You can see the status also. Okay, so most of the time, okay, when you install the operating system, it is turned on. It is like this. Let me show you. The status is turned on and you will see the green color. So if it is turned on, this is the possible reason that this firewall is blocking the ping request. So you need to turn it off. How will you turn it off? You will go to Windows Defender, turn Windows Defender firewall on or off, and you can turn it off from here. Okay, so this is the fourth possible reason. It might be having some other reasons. So these are the the common possible problems. And guys, sometimes we get this message. Okay, destination host unreachable. Okay, so when we get this destination host unreachable, let us try to understand. So let us say this is our PC IP address and this is the router IP address 192.168.1.100. Remember the router IP address. Okay, now we want to ping google.com, or let us say we want to ping any other device. Let us say the IP address of this server is 192.168.3.1. Okay, when we ping, okay, we will open the command prompt of this computer and we will type ping 192.168.3.1, and what message we are getting here? Guys, what is the error message we are getting here?
Destination host unreachable.
Destination, is it pinging? What does it mean? Not pinging, right?
Yep.
So we should know what is the reason, okay, of this destination host unreachable. So guys, whenever we get this message, okay, one of the possible reason, the most common reason of this destination host unreachable messages, routing is not configured. What is the reason of getting this destination host unreachable, guys? Remember this, write it down. It is very important. Destination host unreachable means what?
Routing is not configured.
Routing is not configured. The question is where the routing is not configured. You will get
At
the
the
IP
destination.
address also. If you see, what is the IP address here? 192.168.1.100. On this device, the routing is not configured. So this device is our router or not? 1.100.
Yes.
So you will go to this device and you will check, okay, whether the routing is configured or not. So you can configure it. Okay, one more possible reason. Okay, when you configure the access control list, when you block any IP address, in that case also you will get the same message. Destination host unreachable. Clear, guys?
Yes.
Then let us discuss, okay, what IP addresses we can't use. Okay, as we have discussed, guys, what is the range of class A? Anyone, what is the range of class A? Guys, let us have the interactive session.
0 to 127.
0 to 1. Okay, theoretically, the range is from 0 to 127, but we cannot use 0. We cannot configure the IP address starting with 0. Okay, if you try to configure, you will get the error and it will say that it is the invalid IP address. Let me show you. So let us configure the IP address starting with 0. If you see, it is saying that 0 is not a valid entry. Please specify a value between 1 and 223. Clear? Can we assign the IP address starting with 0?
No.
No.
No. Okay. Theoretically, the range is from 0 to 127, but we cannot assign the IP address from 0. And guys, what is the last network
225.
in
127.
in
127.
class A?
127.
127, right? So again, we cannot use the last range as well. Okay, it is usable. Okay, it is usable for other purpose. So 127, it is reserved for loopback addresses. Okay, again, theoretically, okay, we cannot. The range is from 0 to 127. We cannot use 0, and we cannot use. We can use in the sense we cannot configure 127. We can use it. Okay, in other way. I will show you how to use it. So we cannot configure 0, we cannot configure 127 as well. Let me show you. Let us try to configure 127 as 127. As soon as I have configured 127, okay, it is throwing the error. It is saying that IP address starting with 127 are not valid IP address because they are reserved for what, guys?
Loopback
Loopback
address.
addresses.
Loopback addresses. I will tell you what is loopback address. Just remember, okay, we cannot use 127 because it is a loopback address. All right. So we cannot use 0, we cannot use 127 in class A. So the range we can use from class A is from 1 to 126. Using in the sense configuring, we can configure the IP addresses from 1 to 126. Then, as we have already discussed, we cannot use the first and last IP address, network ID and broadcast ID. We cannot use class D. We have already discussed. Class D is for multicasting. Class E is for it is reserved for research and development. And we are having another range. Okay, the class B range from 169 to 169 to 54.0.1 to 169 to 54.255.254. This range, it is reserved for APIPA. Again, I will tell you what is the reason, what is the meaning of APIPA. Just remember, we cannot use, okay, we can use, we can even configure it, but it is not recommended to use this range because it is reserved for APIPA. I will show you. Okay, APIPA stands for Automatic Private IP Addressing. So guys, now what we will do, we will try to understand what is loopback address, what is the use of loopback address, what is the use of this APIPA range. So loopback address or 127 network, it is used for testing your local device, local TCP/IP protocol, LAN card, driver, etc. What is the purpose? Okay, why it is used to test it? Let us say you are pinging, let us say google.com, and you are not getting the reply. So it is not always mean that there is a problem on the destination network. There might be a problem on your local computer or not.
Yes.
Is it possible to have the problem on your local computer or not? So instead of
Yes.
going directly to the destination, we need to check our local computer. How will you check our local computer? We will use the loopback address. So what this loopback address will do, it will ping the local computer. If it is getting the replies, which means our local computer is fine, we need to check the destination computer. Okay, so what it will check, this loopback address, it is used to test, it will test your TCP/IP protocol, it will check your LAN card, and it will check the driver without connecting another device. Okay, so what it will do, it will send a ping command to itself, to the local computer, and the commonly used loopback address is 127.0.0.1. Let us verify it.
So do we need to configure, or it will
No
be
need, no need, no need.
by default?
By default. Okay, did we
Okay.
configure anything? We didn't configure, right?
No.
Let
No,
us
we
ping
didn't.
127.0.0.1.
No.
Okay, it is pinging. You can try. Okay, you can try on your computers also. I will give you 1 minute.
Okay.
It will ping. It is pinging. That is why you are able to communicate with.
Yes, ping.
All right. Others, did you try?
Yeah, it's pinging.
Okay. Zamran, Mahmood, Salman.
Yeah,
Is
yeah,
it
yeah.
pinging, right?
Ping.
Yes.
Okay. So this is the use of loopback address, and we cannot assign it. Now, let us see what is a PIPA. A PIPA we can assign, guys, but it is not recommended. Okay. So what is the use of a PIPA? Let us try to understand. So guys, you know DSCP concept. What is the meaning of DSCP? We have discussed in our basic classes.
So assign IP address automatically.
To assign the IP addresses automatically. Let us say we are having some computers. And we are having the DSCP server as well. Okay, and we have configured this DSCP server to assign the IP address from 192.168.1.0, and the subnet mask should be 255.255.255.0. Then the gateway should be 192.168.1.1. So what this DSCP server will do, it will assign the IP addresses from this range, 1.1, 1.2, 1.3, etc. So we are having so many computers, so it will assign the IP addresses to all the computers. Let us say, guys, this DSCP goes down.
Mhm.
Okay, if this DSCP goes down, can these PCs get the IP address from 1.0 network?
No.
No. So in this case, if the DSCP is not available in our network, the operating system of this local computer, it will not keep the adapter empty. So it
Okay.
will put the IP address from this range automatically, APIPA. Okay, it will configure the IP address from the APIPA range. So it is reserved. These IP addresses are reserved in case DSCP is not working, the IP addresses will be assigned from this network. It will be assigned, okay, there is no doubt. It will be assigned, the computer will accept the IP address from this range, but it is not recommended to use this IP addresses. It is reserved for APIPA. Clear?
Yeah.
So only in case of you have selected the option obtain the IP address from DSCP. In that case, it will assign the IP address from APIPA. Now guys, again, yeah, any doubt?
No.
All right. Now again, the IP addresses are divided into private and public IP addresses. Any idea, guys, the difference between private and public IP address? Just give
Yeah.
it a try.
Private is the network IP address which gives by the network, and public is like from the ISP.
Very good. Okay, you are almost there. Now, guys, let us try to understand what is the difference between private and public IP address. We'll take this example to understand the private and public IP address. And guys, if you remember, we have some temporary solutions to save the IP addresses. What are those two temporary solutions? Still, we are using IP version 4. Okay, because
Subnetting.
of two temporary solutions, subnetting and NATing. Remember that?
Yeah.
Yes.
Okay, we will discuss about NATing also. Okay, we will see what is NATing as well. So just listen carefully. What is the use of private and public IP address? So we will take this example to understand the private and public IP. Let us say there are three organizations: ABC, PQR, and XYZ. All these three organizations, they are having their own LANs. Okay, they are having two, each organization is having two PCs and they are connected to switch. And guys, after connecting the devices to the switch, after having the physical connectivity, all these three different LANs, they are using the same network in their LANs 192.168.1.0. Okay, guys, so is there any problem here if all these three organizations are using the same network? If you see the same IP address 1.1, 1.2 in all the three LANs, is there any problem if they are using the same IP addresses in their LANs, in their
Yes.
networks?
It might be.
Okay, in this
It's a-
scenario, do you see any problem?
Yes.
No,
Where is
no,
the problem?
no. If they are not connected,
No.
actually,
Very good.
Okay, the switches are different.
they are
They are
different
not
network.
connected, and they are not connected, right?
Yeah.
Yeah.
Are they connected with each other?
No, no, no.
No. So there is no problem. They can use it. But where is the problem? When these
we connect.
devices, okay, let us say all these three networks, they are connected to the internet. Okay, they are having their routers. Then they have got the internet access. So now all these three networks, they are connected via internet or no?
Yes.
Now let us see what is the problem. Okay. Okay, let us see what is the problem. Now let us say 192.168.1.1 of ABC wants to open the Cisco.com. What is the source here?
192.168.1.0.
192.168.1.1.
1.1. And what is the destination?
Cisco.com.
Cisco.
Cisco.com. The request will go to the router. Router will forward the request to internet or ISP. ISP will forward the request to Cisco.com. Now guys, Cisco.com will see that the request is coming from which IP address?
1.1.
How many 192.168.1.1s are there?
3.
3. So this Cisco.com will get confused or not? Whom to
Yes.
respond? And this problem, it is known as IP conflict. What does it known as?
IP conflict.
So we have one specific terminology. If you configure the same IP addresses on multiple devices, it is known as IP conflict. You will face some issues. Your network will be down. Okay, and it is due to IP conflict. So this Cisco.com gets confused or not?
Yes.
Yes.
Whom to send the response, and it will drop the packet. This is the problem. Okay, and whatever the IP addresses we are using in our LANs, it is known as private IP address. Okay, remember the terminology or write it down. Okay, whatever the IPs we are using in our LAN, what is it known as?
Private.
Private IP address. Okay, and what is the problem with the private IP address? We cannot directly access the internet. Clear? Can we access the
Yes.
internet using private IP addresses?
No, no.
No, because it is used by multiple organizations. Here we have taken the example of only 3 networks. but all over the networks, okay, all over the world, millions of networks are using the same networks in their LANs. Okay, so with private IP addresses, we cannot directly access the internet. All right. So what is the solution? The solution is you should have the public IP address. What is the solution, guys? To provide the internet
IP.
access to the LANs, we
You
need
should
the
have the
public IP.
public ID.
Public IP.
Okay. Solution is public IP address. Now, what is this public IP address? Let us try to understand. Public IP address, it is a unique IP address all over the world. Public IP addresses are unique all over the world. It is like mobile number. Guys, can two mobile phones have the same mobile number?
No.
Can we have two mobile phones with the same mobile number?
No.
No. The same way, all over the world, devices cannot have multiple devices cannot have the same public IP address. They are unique. Okay, now ABC will purchase one public IP address. Let us say 1.1.1.1. PQR will also purchase one public IP address 2.2.2.2. And XYZ will also purchase one public IP address 3.3.3.3. Again, the same scenario. 1.1 of ABC wants to access the Cisco.com. What is the source?
1.1. Okay.
Let me write it here.
198.168.
Okay, here. Okay, the source is 192.168.1.1, correct? And what is the destination? Cisco.com. So the request will go to this router. And guys, this router of ABC, this time, it will not send the request with this private IP address. It will change the private IP address. Okay, the source to public IP address. Destination will be same. Then it will send the request using this public IP address to the ISP. ISP will forward the request to the Cisco.com. Cisco.com will see where is the request coming from. 1.1.1.1. It doesn't know. Okay, the request originally it is initiated by 192.168.1.1. Okay, now 1.1.1.1 is the public IP address and it is the unique IP address, and there is no problem here. There is no IP conflict. So Cisco.com will send the response back to ISP. Excuse me. ISP will send the response back to this router, and this router knows who has initiated the request in the LAN. So it will forward the response to 192.168.1.1. So from this slide, okay, you need to, as of now, you need to take only two things. I will tell you the third thing also. The first thing is you cannot directly access the internet using private IP addresses. If you want to access the internet, you need public IP address. Clear?
Yes.
Okay, so what are the two things you need to remember, guys?
We cannot access the internet with a private IP.
Directly with private.
Directly
Okay.
with the
And to access the IP, the internet, which IP we need?
public IP.
Public IP address. Clear, everyone? Any doubt till here?
Yes.
Any doubt?
No.
Any confusion?
Okay.
No.
Asar, Mustafa, Asrar, Mustafa, Mahmood, Salman. Any doubt?
No. No doubts.
No.
Okay. Now, guys, if you see, when this PC 192.168.1.1 is sending the request to Cisco.com, the request is going to this router, and what this router is doing, guys, before sending the request to the internet, what this router is doing?
It's changing the address.
Yes,
Private
very
address.
good. It is changing this private IP address to public IP address. Then it is sending the request to internet on.
Yes.
This concept of changing the private IP address to public IP address and sending the request to the internet, it is known as NATing. Clear?
Yeah.
Okay, so what is NATing here? It is used to translate, changing or translating. The correct terminology is translating. Okay, so translating the private IP address to public IP address to access the internet. Clear? This concept is known as what?
NATing.
NATing. Now you might be wondering how the NATing is saving the IP address. We have discussed in our basic classes, NATing saves the IP address, correct? So with the help of NATing, okay, let us say in your LAN, these two private IP addresses, they can access the internet using only one public IP address, and it will allow maximum 65,000 private IPs to access the internet using one public IP address. Is it saving the IP addresses or not? Otherwise, we need to we need to purchase 65,000 public IP addresses for all the PCs to access the internet. So instead of purchasing 65,000 public IP addresses, we are purchasing only one public IP address. This public IP address is allowing 65,000 private IP addresses to access the internet. Is it saving the IP addresses or not?
Yes.
Okay, clear, guys?
Yes, clear.
And this concept is also known. Okay, so allowing multiple private IP addresses to access the internet, it is also known as patting. Clear? Shall we move forward or any doubt?
Yeah. No, I don't
No,
have
what
it.
regarding the patting, I didn't get.
All right. Let us try to understand. Okay, we are having a concept of natting. Okay, so in this natting, we have different options. Okay, the first option is static NAT. The second option is dynamic NAT. If you are performing static NAT, dynamic NAT, okay, again, it is also known as patting. So with static NAT, if you are having, let us say, two computers and you are performing static NAT, you need to have two public IP addresses. If you are having 65,000 private IPs and you are doing static NAT, then you need to purchase 65,000 public IPs. The ratio is 1:1. So is this static NAT saving your IP addresses?
Hmm.
Is it saving your IP addresses? Guys,
No.
it is not saving, right? Okay, so to save the IP address, we need to perform PAT. What this PAT will do? It will map the
Okay.
multiple private IP addresses to access the internet using only one public IP
Hmm.
address. Is it clear now?
Yes, clear.
Who was having
Yes.
this doubt?
Salman.
Salman? All right.
Yes. Yeah, it's clear now.
It is clear, right? So patting means it will allow multiple private IP addresses to access the internet. It is also known as NAT overload. NAT overload, PAT. Okay, again, everything is natting. Now, guys, we have already discussed, we have already seen the difference between public and private IP addresses. Let us summarize them. So, guys, public IP addresses, they are used on internet. Private IP addresses, they are used in your LAN. Public IP addresses, they are recognized on internet. Private IP addresses, they are not recognized on internet. If you try to access the internet using directly from the private IP address, your request will be dropped because the private IP addresses, they are not recognized. Public IP addresses, they are globally unique, like your mobile number. Whereas the private IP addresses should be unique in your LAN. So let us say you are having some PCs in your LAN. We are using 192.168.1.0 and you are assigning the IP addresses like 1.1. So if this 1.1 is assigned to one computer, you cannot use the same IP address on other PCs in your LAN. Okay, it should be unique like 1.2, 1.3 and 1.4. So it should be unique in your LAN. And how will you get the public IP address? You need to contact the service provider and you need to pay to get the public IP address to the ISP. Whereas, how will you get the private IP addresses? It is provided by us, the administrators. Okay, and it is for free. So, guys, you need the public IP address only when you want to deal with the internet. Okay, if your requirement is like you don't want to provide the internet access, then you can go with the private IP addresses.
You don't need to pay to any. Clear? Now guys, you might be wondering, okay, with the help of private IP address, we cannot access the internet directly. We need the public IP address. Now, how will you get the private IP address? From where you will get the private IP address? From where you will get the public IP address? We need to understand. How will you recognize that it is the private IP address? How will you recognize that it is the public IP address? We need to understand that. So guys, what is the range of class A?
0 to 127.
0 to 127. So in this range, some networks are reserved for private IP addressing. These are the networks in class A, like 10.0.0.0 to 10.255.255.255. These networks are reserved for private IP addressing. Using these networks, you cannot access the internet. Except these networks, all the networks from 0 to 127, they are the public IP address, or 1 to 126. Okay, 0 and 127, we cannot use them. So 1 to 126, they are the public IP address. Clear?
Yes.
What is the range of class B?
128 to 191.
128 to 191. Again, in the same range, some networks are reserved for private IP addressing. Okay, the networks in class B are 172.16.0.0 to 172.31.255.255. These networks are reserved for private IP addressing. Except these networks, all the networks from 128 to 191, they are the public IP addresses. The class C range is from 192 to 223. Again, in this range, some networks are reserved for private. So commonly you will see these networks 192.168.0.0 to 192.168.255.255. Except these networks in class C, all the networks from 192.192 to 223, they are the public IP addresses. So guys, what is this IP address? Is it a public IP address or private IP address?
192.
Private IP.
Private IP in class C, right?
Yes.
What about this?
Public IP address.
Public IP address. What about this?
192.
Public IP.
192, 168.
Private address.
Private in class C,
Private.
right? Okay, and what about this?
Public address.
Public
Public.
in which class?
Class A.
Class. Now guys, we have seen how to get the private IP addresses. Okay, there are some networks reserved in each class. You will use those networks in your network. How to get the public IP address? Who is managing the IP address? Okay, so there is one organization called IANA. IANA stands for Internet Assigned Number Authority, and it is responsible for the allocation of globally unique IP addresses. So guys, who is managing the IP addresses?
IANA.
IANA. This IANA, okay, it is operated by, okay, the parent company called ICANN. ICANN stands for Internet Corporation for Assigned Names and Numbers. Okay, so let us focus only on IANA. IANA is responsible for the allocating the IP addresses. This IANA, again, it is having 5 branches all over the world. Okay, let us say this is IANA, and it is having 5 branches all over the world. For Africa region, the branch name is Afrinic. For Asia Pacific region, the branch name is Apinic. For Canada, USA, and Caribbean island, Erin is there. For Latin America and some Caribbean islands, we have Nick. For Europe, Middle East, and Central Asia, we are having RIPE system. Okay, these branches, the correct terminology of these branches is RIR, Regional Internet Registries. These are the internet registries. So INA is having 5 RIRs. Let us say you are living in Africa. So you will contact the Africa ISP. okay, whoever the ISP is there in your region, this Africa ISP will get the IP address from Afrinic. Afrinic will get the IP address from IAN. Let us say you are in Asia, or let us say you are in India. All right. So again, you will contact the ISP of your country, ISP India, and ISP India, it will get the IP address from APNIC. APNIC will get the IP address from IAN. This is how it works. This is the chain. Okay. So all you need to do is you need to contact the ISP in your region. You need to pay to the ISP. ISP will provide you the IP address. Okay, without knowing the background. Clear, guys? Any doubt?
Yes, clear.
Now we'll start the subnetting concepts. So to understand what is any idea, guys, what is subnetting? Anyone? Any idea? Just give it a try. Have you ever heard about subnetting? Yeah, guys, can you hear me?
Yeah, no.
All right. What is subnetting? Any idea, guys? Have you ever heard of subnetting?
No,
No idea.
It's like
Let
it's like the apple when you cut it.
pardon?
It's like the apple when you cut it.
Very good. Okay. Now, guys, let us try to understand the subnetting concepts. Before understanding the subnetting concepts, okay, let us revise one concept. If you remember, guys, our basic classes, we are having some computers. And if you want to make these computers communicate in our LAN, it should have physical connectivity and logical connectivity. Remember this point? Guys, remember this point or
yes,
not?
yes.
Okay.
Physical
What is the
analogy.
meaning of physical connectivity?
The cable,
The cable.
switch to switch.
Okay. What is the meaning of logical connectivity?
IP.
IPs should be from the same network, right?
Yes.
192.168.1.0, and I will take the last portion. Let us say the IP addresses are 1.1, 1.2, 1.3, 1.4. Let us say we are having two more PCs. And let us say these two PCs are in different network, like 192.168.2.0. The IP addresses are 2.1 and 2.2. So these two computers will communicate, these four computers will communicate. Can we make the communication between 2.1 and 1.1? Can they communicate with each other?
No. No.
Why?
Yes.
Different IP.
In this scenario, can they communicate? They will not communicate, right? It is not fulfilling the second condition. The logical connectivity is not there. So they will not communicate. Getting the point or any confusion, guys?
Yes.
Or should I explain it one more time? Should I explain it one more time?
No, no, no,
Yeah.
no.
All right. So they will not communicate because the logical connectivity is not there. So just remember this point. If they are in same network, they will communicate. If they are
Okay.
different network, they will not communicate. Now let us see what is subnetting. So guys, subnetting is a logical subdivision of a single network into multiple smaller networks. So what does it mean by this sentence? We'll try to understand. We'll come back to this sentence again. Okay, let us try to understand what is the meaning. Let us say in our organization, we are having four different departments: accounts, marketing, sales, and HR. And each department is having 50 computers each. Okay, each department is having 50 PCs. So each department required 50 IPs for these 50 computers. This is the first requirement. What is the first requirement?
50 IPs.
Each department required 50 IPs, correct?
Yes.
And the second requirement is all the four departments should not communicate with each other. All right. So what we will do,
we will assign the IP addresses from class C. Let us say we will provide the IP addresses or network to accounts department like 192.168.1.0. Okay, we will provide this network. In this network, how many IP addresses we can get? 255, right? Sorry,
Yeah.
256. How many IP
250.
addresses we will get? 256.
256.
What is the requirement?
50.
50. It is fulfilling the requirement or not?
Yeah.
Yes.
Okay. And the second requirement, they should not communicate. So to not to make them communicate, we will provide the different networks to different departments. So let us say if you provide 2.0 network to marketing, these two networks will communicate. Will these two departments communicate?
No.
No. Okay. So we will provide 2.0 to marketing, 3.0 to sales, and 4.0 to HR. So can all these departments communicate now?
No.
No, because they are in different networks, right? So it is fulfilling the requirement or not? Each department is getting 256 IP addresses and all of them are not communicating with each other. Is it fulfilling the requirement?
Yes.
But do you see any problem here with the allocation?
Yes.
Any
Lot of
problem?
IPs.
Pardon?
Lot of
Wastage of
IPs.
IP
Lot of
addresses.
IPs. Okay, if you see here, the requirement is 50 IPs. But how many IPs we are providing?
255.
256. So around 200 IP addresses we are wasting in all the departments or not? If you count, around 800 IP addresses we have wasted, correct?
Right.
So how will you save the IP addresses? How will you minimize the wastage? You will do the subnetting. What is subnetting here? You will take only one network. Let us say we have taken 192.168.1.0 network and we will divide this one network into 4 parts, 4 subnets. And each subnet will get 64 IP addresses. Okay. The requirement was what? 50.
50.
And we are providing how many IP addresses? 60.
64.
First requirement is fulfilling, right? And when we do the subnetting, all these 4 different subnets will not communicate also. Clear?
Yes.
So let us read out this sentence again. What is subnetting? Subnetting is the logical subdivision. We are dividing one physical network, logical subdivision of one single network into multiple smaller networks. And what is the use? It is help us to minimize the wastage of IP addresses. It is minimizing the wastage or not?
Yes.
Okay. So guys, remember the term here. We are using the term minimizing the wastage. It is not eliminating the wastage. Still okay. What is the requirement? 50, right? Still
Yes.
we are providing 64 IP addresses or not?
Yes.
So around
Yes.
12 IP addresses are wasted. Wasting in the sense you can use them in future, but it is not eliminating the wastage. It is minimizing the wastage. Clear the idea? What,
Yes.
what is subnetting? All right.
Yes.
Can we see some examples or tomorrow?
Sure.
Pardon?
Yeah, sure.
We can see the example, right?
Yes, yes.
All right.
Today or tomorrow?
No.
Yeah. Okay.
Okay. So subnetting can be performed in 2 ways. So guys, we can do subnetting in 2 ways. The first method is known as FLSM, fixed length subnet mask. The second method is known as VLSM, variable length subnet mask. So when we perform VLSM, when the requirement is fixed, when the requirement is same. In our previous example, what was the requirement for all the 4 departments?
50.
50.
So it was the same requirement or not for all the requirements, for all the departments. In that case, we perform FLSM. If you see all the departments, they need 50 IP addresses and we are providing 64 IP addresses each, okay, by performing FLSM. Okay, it is not always that all the departments need same number of IP addresses. Okay, the requirement might be different. Let us say in this example, the first department needs 50 IP addresses. Second department needs, let us say, 28 IP addresses. The third department needs 30 IP addresses. The fourth department needs 100 IP addresses. So in the second example, is the requirement same here?
No.
No. So when the requirement is not same, when the requirement is variable, in that case, you will perform what?
VLS.
VLSM. Okay, so guys, in our examples, we will see only the FLSM. In our course, we will see only the FLSM. All right. Now, you might be wondering, the requirement is 50 here, and we are providing 64 IP addresses. So from where we have got this number 64? Why we are not providing exactly 50 IP addresses? Why we are not providing 55 IP addresses? Why we are providing 64 IP address for 50 requirement? Here also 50 requirement, 64 IP addresses. We are providing, the requirement is 28. Instead of providing 28 IP addresses, we are providing 32. For 30 also 32. For 100, 128. From where we are getting these numbers? Let us try to understand. So guys, these numbers we get from this 2 power table. So the 2 power table is like 2 power 0, 1, 2 power 1, 2, 2 power 2, 4, 2 power 3, 8, 2 power 4, 16, 2 power 5, 32, 2 power 6, 64, 2 power 7, 128, and so on. Now, what is our first requirement?
50.
50. So we need to see where is this 50 falling. 50 is falling between 32 and 64, correct?
Yes.
Yeah.
Yes.
Okay, can we go with 32? Our
No.
requirement is 50. If we go with 32, there will be a shortage of IP address. So we need to select the maximum number, that is 64. From here we have got 64. What is our second requirement?
32.
100.
28.
Okay,
20.
28, right? 28 is, it is falling between 16 and 32. Can we
Yes.
go with 16?
No.
No, we will go with 32. From here we have got 32. For 30 also the same thing, it is falling between 16 and 32. We will go with 32. For 100 also it is the same thing. It is between 64 and 128. We will not go with 64. We will select 128. Clear?
Yes.
All right. So let us continue tomorrow. And tomorrow or Monday, okay, you will have 2 days time to revise all the fundamentals, right? So let us continue on Monday. All right.
Okay, sir.
So guys,
Got it.
on one condition, you
Mhm.
need to revise all the basic topics.
Three classes.
Okay, otherwise it will not serve the purpose of having the class on Monday. It is not serve the purpose of having the holidays. All right.
Yeah.
So please
Okay.
revise the things. See you on Monday. Take care, guys.
Sir, you will send for
Thank
today
you.
also? Same.
Yeah, I will send it.
I sent the request to accept your
Okay,
this
just give me
yesterday's.
just give me 1 second. I will provide you the